What's up? I'm back. It is currently 2020. The month is May. My hair looks like a homeless person's hair because I haven't been able to get a haircut in the last 75 years. Look at me. I look horrible. But I'm not going to fix it. You can't make me. I'm going to do whatever I want to do. Okay? And what I want to do right now is I want to talk to you about language. And specifically, I want to talk to you about how the brain processes language because it's cool. And there's a lot of questions about language that we don't really know. Like, where did it come from? Is language even a human invention? Is it something that's intrinsically human? Is there a part of the brain dedicated to language processing? Or is it just the whole brain kind of adapting itself to work really well with this thing that we created? And there isn't really a lot of good answers to this, but we can kind of get close. Before we get too far into that, though, I need to talk to you a little bit about just basic neurology. And when I say basic neurology, I mean basic neurology, because I don't know anything about neurology. I'm not a neurologist. I'm a computer science major, and I'm a freshman. I'm dumb, okay? So we're just going to talk about like the super basics that you need to understand this paper. So, brain, what's it made of? Neurons. What are neurons? They're little tiny cells. Some of them are big, actually. Don't know why I said tiny. That's not totally always true. And they transmit electrical signals, and the electrical signals work in really neat ways, and they make human consciousness, which is rad. I like being conscious. I like being alive. Pretty cool. Thanks, brain. The brain is subdivided into two smaller halves called the right and left hemisphere. And these hemispheres are also subdivided into little smaller sections that do their own thing. So different parts of the brain do their own thing. They work together. It's not just like the brain as a whole does everything and all parts do all things. It's like subdivided. So different parts are like, this part's in charge of making you breathe and stuff, and this part's in charge of like the ability, like your senses. And anyway, that's how the brain works. Different parts do different things. There's hemispheres to it. It's cool. It's a cool thing. I like being consciousness, dude. Who understands it? So anyway, another term that I have to define for you really quick is aphasia. So when we're talking about language disorders, aphasia is a huge thing because aphasia means the loss of written or spoken language through brain damage. And that's what we're really going to be studying to try to answer the question of, is language an intrinsically human thing? So in order to talk about language and the brain, there's one guy that we have to talk about right away. This dude's name is Pierre Paul Broca. Now, Broca was a French surgeon back in the 1860s, and he worked at this long-term care facility. And he had this patient that he wrote a paper about, and this patient could only say tan over and over. He would be like, tan, 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 tan. Didn't really have to provide an example. Saying he could only say tan probably communicated that to you just as well as anything else I could have said, but I did it anyway, and you can't stop me. It's already been recorded. Anyway, back to the topic at hand. So we noticed this guy could only say tan. And eventually the guy died, unfortunately, but obviously because it was 1860 and he would be dead by now. And Broca decided to do an autopsy on him to look at the damage that was in his brain. And he noticed a softening of the inferior frontal gyrus of the brain, which is a region in the frontal lobe. It's like on a ridge of the brain. You don't need to actually know that. It doesn't really matter where it is. Actually, it does kind of matter. It matters that it's in the left hemisphere for reasons that we'll talk about later. So after further research and seeing other people who had similar types of aphasia as this guy, Broca noted that there was always kind of this damage to that inferior frontal gyrus. And it was always in the left hemisphere of the brain. And so Broca noted that maybe that area was responsible for some language processing. So he published that. So this area of the brain is going to be called the Broca's area. So let's jump a couple of years later. We're in Germany now. There's this guy whose name is I forget what's his first name. Karl. His name is Karl Wernicke. He's a German neurologist, and he noted kind of a different type of aphasia. Oh, sorry, I have to backtrack. This video is all over the place. I don't care. You can't stop me. So, backtracking a little bit, people with that aphasia where they couldn't, like there's like the guy who's saying tan, 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 they can't create speech, that's typically called Broca's aphasia. And Broca actually objected to this name because he thought that the people that he was talking to who couldn't create speech, he thought that they could actually understand him. So he didn't think it was a true aphasia. But the world didn't care about what Broca wanted. They called it Broca's aphasia anyway. Too bad, Broca. You're pretty famous now, so at least in the neurological world, so deal with it. You got something. Anyway, so back to Wernicke. Wernicke noted an opposite type of aphasia. So the patients he was talking about or interacting with, they could actually speak fluently, but they couldn't like understand anything that they were saying. They would just be saying nonsense words, and they couldn't like you couldn't communicate with them. They were just saying nothing. So Wernicke also noted through autopsy that this aphasia was also attributed to a specific region of the brain, specifically the posterior portion of the left superior temporal gyrus, which you also don't have to know where that is. We're going to call that Wernicke's area. And Wernicke noted that damage was also always in the left hemisphere. So Wernicke took his knowledge and Broca's findings from earlier, and he created this model of the brain where the Wernicke's area and Broca's area worked together to process language inside of the brain. And he said that aphasia could develop if either the Broca's or Wernicke's areas were damaged or the fiber tract that connects the two. So that's the model that Wernicke created. And that's generally sort of, like there's been some small changes, but that's generally the model that's taught today. So, seeing that, you would immediately assume, well, okay, cool. So language is like an intrinsically human thing. There is a part of the brain that's dedicated specifically to language. And yeah, that would be a reasonable conclusion to draw if I had given you all the information, which I hadn't. Because it actually is way, way, way more complicated than that. Because it's the brain, and the brain doesn't like to be simple ever. So different analysis methods, specifically linguistic analyses of people with Broca's aphasia, revealed that people with Broca's aphasia couldn't actually understand everything they were being told, like we'd previously thought. They really struggled with sentences with complex grammatical structures in them. So now we think of Broca's area as more of a syntactic processing center rather than a specific language center for the brain. So that kind of throws a wrench in things. Maybe, maybe we don't have a specific language area. And then also, more advanced neuroimaging techniques that were developed later revealed that the damage to the brain of people who have aphasia is very, very rarely isolated to discrete brain regions. So that also kind of indicates that it's way, way, way more complicated. People can have the same type of aphasia with different brain damage. It's not just two areas in a fiber tract. It's a much, much more complicated system. So with that knowledge, maybe things become a little bit muddier. And we haven't even talked about multiple languages yet, because that's obviously like a huge part of language. There's tons of them. There's sign language, there's like English, Chinese, different alphabetical systems. There's all sorts of stuff everywhere that's been developed. So some people decided to do different analyses of people with similar brain damage who spoke different languages. And interestingly, it was discovered that people who spoke Turkish could have damage to their Broca's area, but still wouldn't produce agrammatic speech just because of how closely tied grammar and meaning are in Turkish. So maybe it's not like, because you would assume if language was this universal across all human beings and we all had like a specific part of our brain that was dedicated to processing it, you would assume that damage to those parts of the brain would result in deficiencies, or the same deficiencies in the languages that we speak. There would be some universals. But the Turkish thing kind of makes us think maybe not. But then also, to add even more confusion, as if there wasn't enough, people who speak Chinese, which is a pictographic language, it doesn't even use an alphabet, it's totally different. They can have an aphasia or similar brain damage to somebody who speaks totally different, and they will both have the same issues with naming things. Like naming schemes, they're going to have the same struggles. And then also, people who speak sign language, which isn't even a verbal language at all, will have similar brain patterns to those of people who speak like spoken languages, with damage to like their Broca's areas. So that's even more confusing. Like, because if sign language, because that's a completely different thing, it feels like, but apparently to the brain doesn't care. It's the same thing for everybody. So there are some neurolinguistic universals out there, but there's also some things that aren't universal and are specific to each individual language. And then even more complicatedly, and this is the part that really just like confuses me and kind of makes me draw the conclusion that I drew, is the lateralization of these language disorders, which means like the isolation to either the left or right hemisphere, We had previously assumed that it was always isolated to the left hemisphere, where like the left hemisphere is responsible for language. That's what we'd always thought. But sometimes, in certain people, you'll see damage to the right side of the brain that will result in aphasia. Or language processing will be seen, like people process language and neuroimaging can show that the right hemisphere of their brain is lighting up. And there's a small correlation to like right versus left-handedness, which could play in. But all in all, there's a lot that we still don't know. So, in order to draw a final conclusion and say definitively that language is or isn't something that human beings have by default, I think would be dumb. It would be silly. Because we just don't have that much information. But with the information that we do have, I sort of lean towards thinking that language is more something that human beings invented and that our brains are using areas that are designed for different things and have just sort of adapted them towards language. Like with the Broca's area being a syntactic processing center, syntax is part of everyday life. Like I, as a computer science major, programming syntax is huge. Would I lose the ability to program if I had damage to my Broca's area? Because that's not really, I guess we do call them programming languages. But like, there's just so many unknowns and so many different things, and the network is so complicated. I think language is most likely just something that our brain has adapted to become really good at, but wasn't designed for. So yeah, maybe language isn't necessarily part of being human, but it's certainly one of our most useful tools. And I would have to say that of all human inventions, language has to be the most important one.